Hello, I'm Gary Grimes. I'm the Director of Sales for RF Solutions at Optical Zonu. And today we're going to talk about the SkyShot GPS tester. Optical Zonu has been a long-time supplier of RF over fiber transport solutions for the wireless industry. In particular, our GPS fiber transport is the only such product that is approved by all three U.S. mobile wireless carriers. This is a product that provides an RF connection between the GPS antenna and the base station equipment, BBU, eNode B, Grandmaster timing, server, whatever, and is used whenever the distance between the antenna and that equipment is too long to use coax. It's also an efficient way to provide distribution of GPS to multiple radios, especially when that becomes a large number of radios. At the other end, we have a low-cost point-to-point solution to be used with small cells and enterprise eFemtos. Very often when our equipment is installed, it's installed long before the actual base station equipment arrives on site. So the question is, how do you verify the site is working properly when you don't actually have a radio to connect it to? For this, Optical Zonu has introduced the SkyShot GPS tester. This is a compact, lightweight, handheld, battery-powered unit that can be connected to anywhere along the path, from the GPS antenna all the way to the output of the fiber link itself. Finally, the GPS tester can be used to simplify the deployment of enterprise eFemtos at a customer premises. You simply take the unit and connect it to the GPS antenna puck that comes with the eFemto kit, and using the LED indicator, you can identify possible locations to install the antenna that both give you a strong enough GPS signal and is acceptable to the building owner. There is an app on the thumb drive that comes with the kit that you can plug into your laptop, and you plug the tester into your laptop, and you get a more detailed view showing exactly what satellites you are viewing, the carrier to noise for each one, and it's color coded so you can see which ones are involved in the sync. So this session can be recorded and then saved with the site closeout document. So now let's take a look at what the components are. The SkyShot comes into this compact hard plastic case that fits easily into your toolkit. Here's the device itself. So it's a battery operated unit. You see there's an on-off switch here. You flip it on and the power LED comes on, indicates that the battery is good. The charger fits into this micro USB port, and that's also where the USB cable plugs in to plug into your laptop. On the other side, you see there's the SMA RF connector. This can be connected directly to the antenna, since there is a plus 5 volt DC bias on the center pin, so it will power the antenna and you can run it directly. But of course, anywhere along the RF path, including the output of the fiber link itself. So as I mentioned, one of the applications for the SkyShot is to identify a suitable location for the GPS antenna puck that comes in an eFemto kit. I have such an antenna here. You can see the connector on our unit does have a 5 volts down the center pin, so when we connect, the antenna does in fact turn on. With a low power GPS antenna in an indoor environment where you have a weak signal, you can sometimes wait maybe a minute and a half or more before you actually get lock. So you can actually get a more instantaneous view of what's going on by actually connecting it to your computer. So we have this USB cable that comes with the unit, and remember, we have the micro USB port here, so I'm just going to plug that in and plug this into my laptop. So the Visual View app it's on my laptop, but it actually is included with the kit on this thumb drive. So along with the user manual and other technical information, but you can just run it directly from the thumb drive. You don't have to download it. And when I bring it up, then I'm going to just hit connect to GPS. Now it's actually a live signal coming through. We're looking at a fairly low level signal, but it's acquiring more satellites as we wait longer. And eventually it'll settle down to a steady state and you'll be able to see that, in fact, yes, we have maybe about 4 or 5 satellites that are being strong enough signal for the lock. And this, you can tell by the color coding that it's in fact being used, and plus it tells you down below over here on the screen that there's 4 or 5 signals that are actually be part of the lock. As I indicated in the beginning, the SkyShot can also be used to confirm an installation of our standard GPS fiber transport, which is the standard DAS installation CRAN hubs for all the carriers. So we're going to go over to the lab where you see we have an example of a live system. The rack-mounted unit you see here on the bench is connected to an active antenna on the rooftop. And you would expect, of course, that this be a much more robust signal than we were seeing with the small GPS puck. And here I'm connecting the SkyShot to one of the 16 outputs on the base unit. And you can see over here on our visual GPS view that, in fact, yes, we have a much stronger signal, that we see probably 12 satellites that are actually being used for sync. And this carrier noise is very high, so this is what you would expect to be for a site like this. So a very robust signal that can be used reliably for any network sync. And that's the Optical Zonu SkyShot GPS tester. For more information, please visit us online at opticalzonu.com.